Hi, I am Andres. I will talk today about Bayesian optimization and how we rewrite our hyperparameter search to make it 3 times faster. So we will start talking a little bit about the Bayesian optimization and what was the change that we make on this process to make it faster and more flexible to our problem, to solve our problem. After that, we go to some numbers and some conclusion about this process and how it really works. And that will be all. I am Andres. I'm a team leader on the data science department on Riskified. I have been Riskified for the last 6 years. I study statistics and sociology in the Hebrew University. I was born originally in Uruguay. I am still trying to be a professional basketball player. Still, it's my dream, but I am terrible. But I will not give up on my dreams. A little bit about the Riskified. Okay, Riskified is an AI platform that is empowering the e-commerce revolution. Our main focus is on fraud prevention, but it's not the only thing that we are doing. We are trying to solve really interesting problems. And we are in an AutoML conference, and I will talk about hyperparameter search. It's like not in the same level, but I think that there was a nice introduction at the beginning of this conference that say we are now talking about AutoML all the time, and I share the concept of I think that in 10 years all this AutoML will be considered just ML, machine learning, classical. There is the feeling that AutoML needs to be some process, some end-to-end framework that goes from the raw data until the model, until the final model without the intervention of the human. I think there is some other definition of the process that it will look at the AutoML as more as a process to make machine learning available for non-machine learning experts. Okay, and I think that the biggest goal, from my perspective, of all these AutoML platform and processes is to improve the efficiency of the machine learning and to accelerate the adoption of the machine learning to the public. In Riskified, we really believe on the automation of the processes. When we look at the scale that we are working, without automation, it will be not possible to do it. However, for us, the transparency, the controlling, and the monitoring of this process are critical. And when we look at the process of machine learning or the training of the model, the end-to-end process, we look at the process as more from the perspective of a model assembly line, where we have several steps, and we need to each step. Our goal is to make each step as simple as possible and as automatic as possible. Okay. Today we will focus on the hyperparameter search implementation and the automation that we create on this part. I will talk all the time about the training of the model and the things, but you can think about this process as something bigger, okay? Because the same thing that are applying to the single model and the hyperparameter of this single model also will apply to feature engineering, feature selection, and pre-process. And so you can think about, I will talk about the model, but you can think about this as something bigger that includes some other parts of the process, of the training of the model. Okay, so having said that, we can go and we can start talking a little bit about the Bayesian optimization. Okay, the goal here is to be all on the same page. So what is the Bayesian optimization? Okay, the Bayesian optimization is a sequential process. Okay, that we will train, each step will train and evaluate some set of parameters. All this process will be based on what we call the acquisition function. The acquisition function is used by the Bayesian model to choose the parameters that will be tested. The maximum values on this acquisition function represent the most promising set of parameters to be evaluated. In the plot that we have on the right, we can see that we have two different graphs. The upper graph represents the performance of the model. Okay, the graph below represents the acquisition function. In the upper graph, we can see that we have the red line. This is the ground truth. This is the real performance of the model for each one of the sets of the hyperparameters. Okay, the set of the hyperparameters are represented on the x-axis. Okay, and below we have the acquisition function. Okay, that will represent the maximum of this acquisition function. Will represent the next step that we want to do. Okay, because these are the most let's say, the most promising set of parameters to be tested. Okay, so the process that we are testing is like this. Okay, we will start with some random starting point. We can start with something more complex, and we will go to another model based on the acquisition function. And there is a trade-off that the Bayesian optimization will try to solve. Okay, the Bayesian optimization will try to solve the exploration-exploitation trade-off. From one side, we want to explore all the possible combination of the hyperparameters. We don't want to have an area that we will not explore. But from the other side, we want to focus on the most promising set of parameters. So there will be some kind of trade-off inside this process. When we look at the process and the acquisition function as we saw it, the acquisition function is a dynamic function, okay, that will be updated on the result of the previous set of parameters that were tested. So the acquisition function will represent the expected performance of the model for each set of parameters based on the information that we have from the previous set of parameters that were tested. Okay, so we have a dynamic process that we are trying to optimize, and our goal is to find the best set of parameters. When we look at this process, okay, it's a complex process, and all what I am making it really simple, and I am saying, okay, acquisition function. There is an entire area of research around this topic. It's interesting for me, at least, and there is a lot of information in the internet. You can go deeper. I will say that for us at this point, it's enough to think about this process as some kind of black box. Okay, we will have our Bayesian model. For us, will be some kind of black box that will be responsible to define what are our next set of parameters that we want to test. We will have another component that will be a machine that will be responsible to train and to evaluate this set of parameters. Okay, the output of this process will be the performance of the model. Okay, that will receive the Bayesian model as an input and will update the acquisition function and send to the machine the new set of parameters that will be tested. Okay. This is a loop that will run until we converge on the best set of parameters or when we finish the number of iterations that we allow the process to run. So when we started to work on this project, okay, we were rewriting the whole platform of the training of the model. And one of the bottlenecks that we have in the process was the hyperparameter search. It took too much time. Okay. Our goal was to reduce the runtime of the whole process and to make it end-to-end in some hours or day. But to make this happen and to make the process really fast, to make it converge faster, we need to make some changes. And when we started to look at the process, we understand that if we wanted to make it more faster, we are having some kind of problem because the Bayesian optimization, okay, will solve this problem of finding the best set of parameters on the most efficient way. What does it mean in the most efficient way? It means that it will solve the problem, in average, training the fewest number of models that I need to train. Okay, so for us, efficiency is strictly related with the number of models I have to train to find the best set of parameters. Okay, because my resource in theory are the CPU. Okay, so if I am training the fewest number of models, I am solving the problem in the most efficient way. So the big question that we have here was, okay, how can I make the process faster if I am already training the fewest number of models? Okay, so this was the idea that we have, and this was the problem that we have to solve in our minds. Okay, and we understand that if we want to solve this problem of how can we make it faster if we are already making it as efficient as possible, we need to look at the problem from a different perspective. Okay, so as I say, the Bayesian optimization will solve it the most efficient way. And for a moment, let's try to think, what is the fastest way possible I can solve this problem? I want to make it as fast as possible. What is the way I can do it? Okay, if I wanted to solve this problem as fast as possible, okay, what I need to do is to make a brute force and train all the possible combination of my hyperparameters in parallel. So when the last of these models will finish, I will know 100% for sure what is the best set of parameters for my model. Okay, so this moves us on a different perspective on this process. Okay, because this will be the brute force will be the fastest way of solving, but also will be the most inefficient because I will training all the possible combinations. So our goal was to solve the problem the shortest time without wasting too much resource. Okay, so the trade-off that we are having now, or the trade-off that we are trying to solve, is not to make it as fast as possible, okay, but is to make it as efficiency, is to find the balance between efficiency and runtime. Okay, so when we look at the process, we understand that what we really have to do, okay, is to increase the information that we are generating at each step on the process. Okay, so if we are generating more information at each step, we will converge faster, or at least that was our idea. So instead of training one model on the first step, I will train two models now. Okay, I will say the first one will receive the best set of parameters based on acquisition function. The second one will receive the second best. Okay, let's see what's happening, because now when these two models will finish the training, I will have more information. And the next two steps that I will do, it will be smarter. Okay, I will know better where I should look or explore. Okay, and when these two finish, and I will train two more and two more and two more, so on, until I will find my best set of parameters. Our hope was that I will converge in few steps, but this will generate some inefficient from our perspective, because if in the previous platform I will train 5 models after 5 steps, now I will train 10 models after 5 steps. Okay, so I will train twice the number of models. So if there is some kind of trade-off that I need to solve, or there is some hope that the effect or the impact that I will converge faster will improve or will make the other side of the fact that I am making the process more efficient. Because if we are thinking about that, we are trying to make the process less efficient to make it faster. It's not the more intuitive thing to do. To test this idea, what we create is a really similar framework that we have for the previous one. Okay, we have our search space, that is the same one. Okay, we will have our Bayesian model almost the same than the previous one, but now instead of having only one machine, we will have 3 different machines. Okay, so the first machine will receive the first set of parameters, the best set of parameters that I have based on my acquisition function. The second one will receive the second best set of parameters, but with a constraint, because we say, I don't want to train 3 models that are similar. So the second set of parameters, okay, will need to be significantly different from the first set of parameters that we have. Okay, and the same goes to the third one. The third set of parameters will have to have a significantly different set of parameters than the first one and the second one. Okay, and the process will go like this. So when the first model finishes, it will send the performance of the model to the Bayesian, okay, to the Bayesian model for the set of parameters that it trains, and will receive a new set of parameters to be trained. And each one of the models, when they are finishing, they are sending to the Bayesian model the performance of for this set of parameters, and will receive a new set of parameters. So the process is more dynamic and is constantly updating the acquisition function. And our hope was to converge faster. Okay, so making a long story short, okay, this process, we test several configurations, training 2 models together, 3 models together, 4, 5, 6, and we find that for us the best set was 3 models in parallel. Okay, but if we want, we can change this fast. By the end of the day, is a parameter on our platform. Okay, we see that by training 3 models in parallel, we make the process 3 times faster. The fact that it's 3 models and it's 3 times faster is just a coincidence. There is no straight correlation between these two things. It's not meaning that 4 models in parallel will make it 4 times faster. No, that is not true. The marginal reduction of the time is decreasing when we are adding more models in parallel. Okay, because you are making the fourth model will be less efficient than the third one. So there is some kind of inefficiency, and I hope I was clear by explaining it. In general, by training 3 models, it will be 3 times faster, and the cost of the full process will be 50% more. So if I was training 20 models in the previous configuration. Now I will be training 30 models. Okay, so this is the idea in general. I think that the fact that we reduced the time was great, but by the end of the day, when we realized what we made, the main goal or the real win of this process was the fact that we make our platform more flexible. Okay, and now we can adapt this process to the needs that we have. Okay, that means that not every problem is the same. If we have an urgent problem, we can use six machines to train in parallel to solve it faster. And I think that the fact that we can reduce the runtime of the process by adding more resource is one of the most important things in the process. And I think that when we are talking about AutoML processes, the fact that we can improve and we can reduce the runtime by adding more resource is an important and a really helpful characteristics on this type of platform. So I hope that the message was clear. If not, you can take a look at Medium. I have a blog post on this. You can go deep. And if you still have any question, feel free to contact me by email or by LinkedIn. That is all. So thank you.